Okay, what is meant by the term diffusion? That's very pretty easy. So we can say refer notes. So that's, I'm not going to write it because you already have the definition. The next question is, what property of a gas molecule affects the speed at which it diffuses? Now, if it's a gas molecule, okay, and if it is at same temperature, can I say the property which it can affect is MR, that's molecular mass, correct? We had done that question about HCl and ammonia, right? So over here, the answer will be molecular mass. Next question is B. Helium is a gas which is used to fill balloons. It is present in a very small quantity. Diffusion can be used to separate it from the air. See, now air is a mixture of gas, correct? And it has helium also present in it. So how it can be separated? So today we are going to learn that technique, because you might be come across a word which is called as fractional distillation. So that technique we are going to study, that like how that technique is used, or in what sense that technique is used for. So air at 1000 degrees Celsius is on one side of the porous barrier. The air which passes through the barrier has a large amount of helium in it. So now if there is a large amount of helium in it, so can I say that it will diffuse from a higher concentration to lower concentration? Because that's the air which has a more amount of helium. That's what they are telling to us. Now, why does the air on the other side of the barrier contain more helium? Now, if we talk about the MR, the atomic weight, helium's atomic weight is 4 units. Tell me which is the gas which is present in the largest quantity in air.
Nitrogen.
That's correct. So nitrogen, which is 78%, its mass is 28 units, or 28 grams we can say, for 1 mole. The next gas, oxygen, is 21%, which is 32 grams. So can I say that helium, which is 4 grams, is very, very lighter? So that's the reason that helium is the lightest particle, which will go from, you can say it will diffuse at a faster rate. So we will write that helium diffuses faster than air, because air contains majorly what? Nitrogen and oxygen. Now, what is an advantage of high temperature? We know that diffusion rate will be higher at high temperature. So high temperature, the rate of diffusion will be faster. Rate of diffusion will be faster.
Okay. I didn't understand how to write the equation for like part C.
Yeah, that's okay. That was an extra question. It is not completely from this part, but yes, we will do it. Most of the helium is obtained from natural gas found in USA. Natural gas contains methane and 7% helium. One way to obtain helium would be to burn methane. So now remember, combustion of methane. Combustion means reaction with O2. Okay, reaction with O2. And the product will be always carbon dioxide and water. This combustion reaction is generally a part of organic chemistry. So don't worry, when there will be a kind of term test for you, and if this chapter is coming, they won't ask you any questions which is not related to this. So yes, this question is not related directly to states of matter. So don't worry about that. So the reaction is CH4 plus O2. So whenever there is an organic compound which is reacting with O2, the product will always be carbon dioxide plus water. And we need to balance this equation. So balancing equation is 2O2 giving 2H2O. So this is balancing. Whenever we write an equation, we need to balance. So balancing equations, I hope you know. If not, then when we will be doing a chapter like chemical reactions, so that time we will be doing it. Okay, so don't worry about that. Okay, next is suggest why this would not be a suitable method to obtain helium. See, because we are not getting only helium, we are getting another gas which is carbon dioxide, and I am interested only in helium. So would get a mixture of carbon dioxide and helium. That is why it is not suitable. If I would get pure helium, then yes, it would be suitable for this. And next one is suggest another method other than diffusion by which helium could be separated from the mixture of gases. So now there is a you can say a technique which is called as fractional distillation. So we are going to study about this in today's class, that where you can use simple distillation, where you can use fractional distillation. Okay, and I think this question is pretty much easy because that is something which is related to particle theory. So we know that as the temperature increases, the particle gain more energy, the particles will move faster and there will be more collision. So all that 3 to 4 points needs to be there. So Arpita, fine? Okay. Anybody is having any doubts in the previous topic? Yes. Okay. Let's go for our next topic for today, which is separating techniques. One sec. Yeah. So we are going to start with the topic that's separating techniques. Now there will be like number of mixtures will be present around you and you need to separate those mixtures. So how do we use the techniques for separation? So first technique is magnetic separation. The first technique is magnetic separation. Okay. So for this magnetic separation, the mixture will be, you can say example will be iron powder plus sand. You can use magnetic separation only when one of the component has magnetic property. Okay, one of the component has magnetic property. Second technique, filtration. Where do you think you can use filtration? Which product, I mean, which mixtures you can use filtration? Yes, Arpita.
With liquid and solid.
So, but over here we need to say insoluble solid, because if I add sugar to water, even that is a solid, sugar is a solid, water is liquid, but when I dissolve sugar and water, I cannot use filtration. So important note point over here, filtration can be used for insoluble solid to liquid. Insoluble solid in liquid, sorry, in liquid. Example, mud plus water. Okay, let's say another example, tea leaves from tea. Tea leaves from tea. Now over here, what we need to understand some terminologies which are used in filtration. So I'm going to show you that. So this is going to be the beaker in which our liquid part is going to be collected. This is going to be my funnel. Okay. So the outside one is filter funnel. The dotted line represents filter paper. This is the beaker, or also we can call it as collector. Now let's say there is a mixture which is being poured in this mixture of sand plus water. What will be accumulated on the filter paper? What will be accumulated on the filter paper? When you filter sand and water, Advita, wait. Advita, can you tell me what will be accumulated on filter paper?
The sand.
Yes, correct. So over here on the filter paper, there will be sand. So basically, it will always be the solid particles which will get accumulated on the filter paper, and that is called as residue. That is called as residue. Whenever a solid component is being accumulated, that is called as residue, and the liquid part, this is water, which is liquid, that is called as filtrate. That is called as filtrate. Okay. So sand is residue and water is filtrate. So always remember, in filtration, the solid part is called as residue and the liquid part is called as filtrate. So this is my second technique. So please take a screenshot of this, okay, so that we can go over more and more techniques in the class. One second. So everybody has taken the screenshot. Okay, let's go to the next. Nafiza, you still can't see the screen?
No, miss. It has
One
gone
second.
black.
Now?
Oh, yes, miss.
Okay. Okay, have you taken the screenshot, Nafisa?
Yes, miss.
Okay, fine. So let's go to the third technique. The third technique is evaporation. Now, evaporation is used when there is a soluble solid dissolved in liquid. So soluble solid in liquid. let's say salt and water. For example, if I want salt from seawater. But what is the disadvantage of this technique? Veer, can you tell me what can be a disadvantage of this technique?
I'm not too sure. Would it
Okay.
be that it can no wait, I'm not actually that
No,
sure.
no, no, it's okay. Veer, tell me, it's okay. What is the disadvantage? Why you cannot use this technique always? What could be the drawback?
Would it be that maybe too much energy would be used?
No, not really, Veer.
Yeah, I'm not
Okay,
too sure.
no. Okay, Nafisa, yes,
You cannot get the water back.
exactly. So over here we don't get the liquid component. We can only get the solid component. Let's say salt from seawater, the water will evaporate, but only the salt will be there. But it's not always that I can afford to lose the liquid component. Suppose if I need that liquid component, so then what I need to do? So that's why evaporation is not always used. The drawback liquid component liquid component cannot be collected. Liquid component cannot be collected. So what alternative can be used if I can get both the solid or liquid component? So then the next technique, yes, Nafisa.
Distillation.
Yes. The next technique is simple distillation. The next technique is simple distillation. Now, in simple distillation, the example is we can have two miscible liquids. Okay, two miscible liquids. We do not say two soluble liquids. Okay, we don't say two soluble liquids. We say two miscible liquids, but whose boiling point difference should be more than 25 degrees Celsius minimum. Okay, it has to be a difference of minimum 25 degrees Celsius, or you can use a soluble solid in liquid. A soluble solid in liquid. Now, how simple distillation process takes place, I am going to just show you with the help of diagram. You are not, I mean, for you guys, it's not needed to draw the diagram. So you have a round bottom flask. Okay, there is a rubber cork. So what happens is, let's say there is a mixture of two liquids, let's say acetone plus water. Okay, acetone boiling point is 60 degrees Celsius and water boils at 100 degrees Celsius. Okay, it's a mixture. This is called as condenser. Okay, this is called as condenser, where there will be water inlet, water in, and from here water out. Okay, there will be a collector over here. It can be a beaker or a conical flask. And what happens is, when you heat it, okay, when you start heating, there are two liquids in this. So who has a lower boiling point? Who has a lower boiling point? Can I say acetone? Acetone has a low boiling point. So that acetone will come out first. And since over here water is flowing, okay, acetone is in liquid state. So when it boils, can I say it will turn into gas? Correct? So when it boils, it will turn into gas and that vapors will condense and it will be collected over here. So in the collector, there will be the liquid which has a low boiling point. So that is how you have already separated the two liquids. If there are more than two liquids, even that can be done. But as I told you, that minimum difference should be 25 degrees Celsius. Between acetone and water, the difference is of 40 degrees Celsius. So this mixture can very well be separated using simple distillation. Okay. But what if I have a mixtures, maybe more than two or maybe more than four, they all are in liquids or maybe they are in gas. How do I separate them? So then we use a technique which is called as fractional distillation. Please just take a screenshot of this. Take a screenshot of this. So liquid with low boiling point, will distill it out first. Liquid with low boiling point will distill out first. Till here, any doubts? Yes, till here, any doubts? Advita, Veer, Alishba, Nafisa, Arpita. Yes, guys, are you able to hear me? Please respond.
Yes, miss.
Yes, any doubts till here?
No, miss.
Okay, fine. So let's go to the next technique, which is my fifth technique. That's fractional distillation. Now, fractional distillation is a technique, it's a type of distillation where you get the components are collected in fractions. So even if there's a mixture which have, let's say, the difference in the boiling point even less than 25 degrees Celsius, even they can be separated. Example, separation of gases from liquid air. Separation of gases from liquid air. So let's say for any gas, if I want to separate, let's say I want to separate nitrogen from air. So what I am going to do is I'm going to collect the air. Now air is in form of gas. I'm going to liquefy that air first. so that it will be in liquid state, and then I will undergo, or I will use the technique which is called as fractional distillation. So different gases will come out in fractions, because every gas has a specific boiling point that we have studied in our previous lecture. Okay, every gas will have a specific boiling point. Next one, next where we can use fractional distillation is separation of components of crude oil. Separation of components of crude oil, that is petroleum, crude oil or petroleum. Just excuse me for 2 minutes. Another technique which you can use over here is diffusion as well. So diffusion can also be used. So either you can write diffusion or you can write fractional distillation. Sixth one, yes, Arpita.
How is like fractional distillation? How will it look like?
Sorry, how it looks. Okay,
Yes.
yeah. Fractional distillation looks like, it will be same like distillation, but over here there will be a column. A column will be there, so that what happens is the component which has the lowest boiling point will come out first, means it will go up and it will distill out first. So let me show you one picture. So if you see that there is this crude oil over here, and based on the gas, now over here this is a gas which is having a 20°C boiling point. Petrol, which is having, let's say, 200°C boiling point. Then we have kerosene, which is approximately, no, sorry. Petrol is having around 150°C. Kerosene is having 200°C. Diesel, 300°C. And so on. Means the component which is having the lowest boiling point will come out first, and there are different fractions which are being kept over here. So separation of components of crude oil is a very classic example of fractional distillation. Okay, is everybody clear that how fractional distillation takes place? Yes. Okay, so let's go to the next technique, which is crystallization. Now, crystallization is something where particles, or we can say crystals, let's say example, CuSO4, copper sulfate crystals from its solution. Now, okay, have you all seen sugar candies? You know, there will be some candies on which sugars are coated. Now, how that sugar coating is done, so that's basically a process of crystallization. So what happens in crystallization is, you take a very saturated solution, then you allow it to heat. Okay, you heat it. So you heat the saturated solution until crystals start forming. Okay, then allow to cool the solution. allow to cool the solution. So once when the solution is cooled down, the crystals will start accumulating. Once you cool down the crystals, I mean cool down the solution, allow to cool down the solution, filter the crystals, to remove excess water, filter the crystals to remove excess water. Dry the crystals with filter paper. So that is how you obtain the crystals. So one of the example is copper sulfate crystals from its own solution. Or another example, we can write as sugar crystals from sugar solution. Sugar crystals from sugar solution. This is another technique of crystallization. Please take down the important note points. 1 second. Yeah, so the next separating technique is centrifugation. So example is blood cells from blood. So we take the blood sample, we take it in a test tube and we allow it to rotate in a centrifugation machine. The lighter component will be on the top and the heavier component will be at the bottom. Another example of centrifugation is milk, butter from milk. Butter or cream from milk. Have you seen churning of milk leads to formation of cream? You know, or maybe suppose if we are whipping something, there will be a cream formation. So that cream is always in a lighter weight. Lighter the weight, it will be on the top. So let me show you an image of centrifugation. This is a centrifugation image where you can see there is an instrument where you take the test tube and you rotate it. Once you rotate, depending on the density, the lighter particle, plasma is a lighter particle, lighter in density. And this is heavy in density. Okay. So this is how centrifugation takes place. Advita, yes, any doubts? Advita, Alishba, Nafisa, Veer?
No, miss.
Okay. Now let's go to the next technique, which is sublimation. Okay, now in sublimation, example, let's say if I want to separate ammonium chloride crystals ammonium chloride plus common salt. Sublimation can only be used if one of the component is a sublime compound. One of the component is a sublime compound. Okay. So how sublimation technique is used? There will be a crucible and there will be inverted funnel which will be kept over here. Okay. Wire gauze. Bunsen burner. So let's say there is a mixture of ammonium chloride, a mixture of NH4Cl plus NaCl. Now out of NH4Cl and NaCl, which is a sublime compound? Which is a sublime compound? Yes, which is a sublime compound? B. Yes, ammonium chloride. This is a cotton wool. Okay, now what happens is when you heat it, the ammonium chloride crystals will turn into vapors, and since there is a cotton wool over here, so the vapors will not go out, but it will start condensing over here on the sides of the filter funnel. So this will be crystals of NH4Cl. This will be crystals of NH4Cl. Okay. So this is how we are going to do, we are going to separate the sublimation compound. But yes, one of the important note is we need one of the component to be a sublime compound. Okay. And moving on to the last technique, which is chromatography, very important technique. So everybody will pay attention over here. The ninth one is chromatography. Now, what is chroma? What is chroma? Chroma means to add, chroma means color, and graphy means representation on paper. Now, where is chromatography used actually? So basically chromatography there will be a color representation on the paper. So that's called as chromatography. Example where chromatography is used to separate dyes from ink. Second, it can also be used to detect number of components present in mixtures like amino acids, fruit juices, etc. amino acids, fruit juice, etc. Okay. Now, how exactly chromatography is taken place? So everybody pay attention. For chromatography, you need a paper. Okay, there will be a there is actually a specific paper for chromatography, which is called as Whatman's paper. There's a specific paper for chromatography, which is called as Whatman's paper. Okay, it is called as Whatman's paper. You can also use filter paper, but for better results, the Whatman's paper is used. Then, with the help of pencil, okay, with the help of pencil, you will make a baseline. Baseline should be made up of pencil. Reason because the lead which is present, lead in pencil is unreactive. That's why you use pencil. You cannot use pen, okay, because pen, when you dip it in solvent, it might spread. That's why. So this is the baseline. Then what you will do, you will immerse the beaker, immerse the paper in the beaker containing solvent. So this is a solvent. Now the solvent should be below the baseline. The solvent should be below the baseline. Then you will put a sample over here. Okay. And you will allow the sample to run on the top. Okay. Allow the solvent to run through the sample on the top. So you will see that the paper is getting wet, and there will be, once it crosses the sample line, there will be the separation technique, separation of the components. And you will allow the solvent to run only, like, let's say, not completely at the top of the paper, but you will leave some space, and that you will mark it as a solvent front. That you will mark it as a solvent front. That you will mark it as a solvent front. Let's say there will be two spots visible. So two spots visible, which means there are two mixtures present in it. Two spots visible means there are two mixtures present in it. So let's say this is spot A, this is spot A, and this is spot B. This is spot A and this is spot B. Okay, spot A, spot B. Then what you have to do is, how to know that which is spot A and spot B? Let's say for example, if this is a mixture, the component, and it's a mixture of fruit juice, and I need to calculate that which is a mixture of pineapple juice and which spot is orange juice, for example. So now there is, in a literature, means there is a book where there is a calculation of RF value. RF value is called as retention factor value. So based on the RF value, you can actually calculate that which spot is what, it's corresponding to what. So what is RF value? RF value is called as retention factor. Okay, it is called as retention factor, and there is a formula for RF value. The formula of RF value is distance traveled by spot, distance traveled by spot divided by distance traveled by solvent. So that is how you will be able to calculate the RF value, and RF value is always less than 1. RF value is always less than 1. RF value is always less than 1. Yes, Arpita.
How will you know the distance traveled by the solvent?
With the help of scale. See, over here you have always marked the solvent front. So distance from the baseline to solvent, you will use it with the help of, because once you have marked the solvent front also with the pencil, so you know the distance. You will draw the line. You will use a ruler, and this is spot A. Let's say you want to find for spot A. So let's say spot A from baseline, the distance is 3 centimeter, and the distance of solvent front from baseline is 4 centimeters. So it will be 3 by 4. So RF value is always less than 1. And depending on number of spots, okay, depending on the number of spots, you would be able to find out that, okay, this has this many components. What I'm going to also do is, when like after the lecture, when I share the notes with you, I will also share some video links, like chromatography, like some links of the techniques, so that when you watch the video, you get a better idea that how exactly the technique is performed. Okay, so this chromatography technique is also used for detection if there is some impurity. For example, let me show you that. So let me show you that technique for chromatography. Application of chromatography. Okay, application of chromatography. 1 second. Yeah. One of the application is, let's say I have a chromatography paper. And this is unknown sample. I don't know, it's an unknown sample. I want to find out that what all components are present in my unknown sample. Now, when unknown sample is been undergoing chromatography, there are 3 spots present. Now, these 3 spots individually, let's say this is sample A, this is sample B, and this is sample C. Sample A is showing me spot over here. Sample B is showing me spot over here. And sample C is showing me spot over here. Now tell me which which samples are present in my unknown sample. Veer is going to answer this. Yes, Veer. Can you tell me, this is unknown sample, the black one, it is showing me 3 spots.
Yeah.
And I have individual 3 different samples, sample A, sample B, and sample C. Now I want to find out that in my unknown sample, which samples are present.
Okay. Um.
Okay, can you tell me yes or no whether A sample is present in my unknown sample? Is A sample present in my unknown sample?
It is.
Yes, because see, you have to check the distance. Can I say A is exactly forming the same spot? I mean, at the same place where unknown sample is also forming the spot. The spot position is same, which means definitely it contains sample A. Now look at the B. Look at this spot and look at this spot. Are they on the same position?
No, they're not.
No, which means my unknown sample does not contain sample B. And look at C. Look at C. Are they on the same spot?
They sort of are. So
Yeah, yeah.
maybe
Okay.
it does
So
contain.
yes, so it is sample C as well. So from this, by, like let's say you have an unknown sample, okay, and you know that, okay, this sample contains 4-5 components, and you have that 4-5 components separate also. So all of them you will run through to that component. You will match the distance of the spots, and from by correlating the spot distances, you can find out that it contains which all sample. So this is an application of chromatography also, where you can find out that along with how many components does a mixture contains, you can also find out that which all components does your mixture contain. So this is also one of the application of chromatography. So this is all about chromatography, and this is all about the separating techniques. So with this we have completed topic 2, chromatography. Okay, and now the Wednesday, which no, the Tuesday, which we usually have lecture, but this week due to Eid holidays, Monday, so Tuesday and Wednesday, I'm not going to take lecture because of Eid holidays. I know there will be, like, when your family members will have holidays. So this week we will not have a class on Tuesday. I will also post it on the group. But yes, from next week it will be Sunday, Tuesday again. So next Sunday we are meeting again, and next Sunday we are going to solve questions on the separating techniques. So I will send the notes. I will also send the recording. So before Sunday, just have a recap, have a look up to the notes. Also, I will be sending, as I told you, 2 to 3 small YouTube videos where you can actually have a look on the techniques, how it is performed, to get a better idea. And on next Sunday, we will be solving past paper questions, that how questions on separating techniques are asked. And that will be the closure of topic 2, which is separating techniques. Okay, guys. So with this, we'll end up the session for today. Thank you very much. See you on next Sunday, and wishing you all a very happy Eid, and please enjoy your holidays. Till then, bye-bye, take care, and have a nice day. Bye-bye.
Thank you.
Yeah, bye-bye.
Yes.
Bye-bye.